I think third question also have 4 subdivisions. So we have to answer one by one. What is given in the question? Read the question. A block is in the shape of rectangular solid, has the cross-sectional area of 2.7 centimeter square across its width. So you have the rectangular solid. So better I am going to draw the diagram again. We have the rectangular block. So this is a rectangular block. And what is the area of the block? The area of the block is 2.7 centimeter square. So you have to convert this in terms of meter square. So 2.7 multiplied by 10 power minus 4, right? Yes, meter square. The front to rear length is 11.7 centimeter. What is this front length? Actually, here I can't show the back side of this solid. So this is our front view. Am I right? This is our front view. And what is here? Here we have the back side. Am I right? The back side is called as a rear view. Am I right? So the rear view from the front side to the back side, what should be the length? The length is exactly 11.7 centimeter. What's the length from front side to the back side? 11.7 centimeter. So you have to convert it to meter. So L, which is equal to 11.7 multiplied by 10 power minus 2 meter. Clear? And the resistance of the block is given. What's the value of the resistance? Which is 935 ohm. And this is the conducting material. So it must have the conduction electron. So how many electrons are here? So n number of conduction electrons. Generally, if you have a conductors, you have n number of conduction electrons, and that value is given. That means the n value, n is a small n. So we have to use for indicating the number of conduction electron. How many conducting electrons are there? 5.33 multiplied by 10 power 22. So n value is 5.33 multiplied by 10 power 22 conduction electron per meter cube. That means in a volume, this is a rectangular block, am I right? So in this volume, how many conduction electrons are there? 5.33 multiplied by 10 power 22. So this many conduction electrons is in this conduction conducting material, conducting block. Okay, and what else they give? And the potential difference of 35.8 volt is maintained between its front to the rear face. That means again, so from where to where you are going to connect the volt? From the front side to the back side. That means front view to the back view. How much volt you are going to apply? We are going to apply the voltage of 35.8 volts. So the voltage we are going to apply is 35.8 volt from the front view to the rear view. So these are all the values they give in this question. By using all this value, we are going to answer for the 4 question. What is given in the first question? In the first question, we are going to find what is the current in the block, because we are applying the voltage, am I right? So we have to find the current. So in the first question, we are going to find the current value, which is I. And in the second question, what we are going to find? We are going to find what should be the current density. So if the current density is uniform in the block, what should be its value? So that means we are going to find the value of the current density, J. Clear? And third question, we are going to find what should be the value for the drift velocity of the conduction electron. So drift velocity is indicating by the symbol V suffix D. That means we are going to find the value of this drift speed of a conduction electron. And finally, in the fourth question, we are going to find what should be the electrical field in the block, because when you apply the voltage, electrical field must be there. So in the fourth question, we are going to find the value of electric field. So these are all the 4 answers we are going to find by using these values. Understand? So let's we calculate the answers one by one. So first we are going to find what should be the value of the current. So I'm going to use the Ohm's law. V which is equal to IR, V which is equal to IR. Therefore, I which is equal to V over R. Am I right? I'm going to use the Ohm's law. So voltage across front to the back side is 35.5. So 35.8 over, and the resistance is 935. Am I right? So 935. So by that we can easily calculate the amount of current. Am I right? So 35.8 over 935. Right? So the answer is 0.038, which is exactly 3.83 multiplied by 10 power. So 3.83 multiplied by 10 power minus 2. What's the unit for the current? The unit for the current is ampere. Clear? So A. So this is the answer for the first question. The second question, we are going to find what should be the current density. What's the current density? B part, we are going to find the current density. We know the formula, current density, which is equal to I over area, right? This is the rule, am I right? We have the current value from the first part, and the area of the block is given, which is 2.7 multiplied by 10 power 4 meter square. So we have both values, so we can easily calculate the value of the current density. So the current from the first part is 3.83 multiplied by 10 power minus 2 over, what should be the value of the area? 2.7 multiplied by 10 power minus 4. 2.7 multiplied by 10 power minus 4. So what's the answer for the current density? So 3.83 multiplied by 10 power minus 2 over 2.7 10 power minus 4. So the answer is 141.85. 141.85. And what's the unit? The unit for the current is ampere, and the unit for the area is meter square. So ampere over meter square is the unit for the current density. So this is the answer for the second question. Clear? And third question, we are going to find what is the drift speed. Drift speed. So we already know the relation connecting the drift speed as well as the current density. What we studied in the theory, current density, which is equal to NeVd. What is N? N is the number of conduction electron, E is the charge value, and Vd is the drift speed. So this is the relation connecting the current density as well as the drift speed. I'm going to use this rule for finding the value of the drift speed, right? So we have to rearrange this equation in terms of drift speed. So V of d, which is equal to J over N multiplied by E, and we have the value of current density in the second part. So I'm going to use this value. So 141.85 over N value. What is N? N is nothing but the number of conduction electron in this volume, in this block. How much number? How much electrons you have? 5.33 multiplied by 10 power 22. So the N value is 5.33 multiplied by 10 power 22, and the charge of the electron is nothing but, we already know this is a constant, 1.6 multiplied by 10 power minus 19, right? So we are going to calculate 141.85 over 5.33 multiplied by 10 power 22 multiplied by 1.6 10 power minus 19. I got the answer as 1.66 multiplied by 10 power minus 2. 1.66 multiplied by 10 power minus 2. And what's the unit for the speed, which is meter per second? Okay. So this is the answer for the third question. And finally, we are going to find the value of the electric field. So electric field, we can use the rule, because in chapter number 24, electric potential, we studied the rule, right? So what rule we studied in the electric potential? Potential which is equal to electrical field multiplied by the distance, am I right? So here the distance we already have, electrical field we have to modify, rearrange this, and the voltage we have in we have the value of the voltage in the question. So I am going to remodify this equation in terms of electrical field. Therefore electrical field which is equal to V over D. Actually here the D is nothing but the distance from the front side to the back side, right? Because they already mentioned in the question the distance from the front to rear length is nothing but our distance, so which is 11.7 centimeters. So what I'm going to do, I'm going to take this D is in terms of length. Clear? So the length, so if you take the block, this is our block, am I right? This is our block. From the front side to the back side, sorry, not this one, this length from the front side to the back side, what's the length? 35.8 centimeter. No, sorry, 11 point something, I think so. I wrote the voltage. From the front side to the back side, the length is, I think, 11.7, right? 11.7 centimeter. So here the length is nothing but the D. And the voltage from the front side to the back side, how much voltage we applied? We applied the voltage as 35.8, right? So the voltage applied from the front side to the rear side, we applied 35.8 volt. So 35.8 over our distance from the front side to the back side is 11.7 multiplied by 10 power minus 2 will give the value of the electrical field. 35.8 over 11.7 multiplied by 10 power minus 2. I think the answer is 305.98. 305.98, and the unit is volt per meter. This is the answer for the fourth question. Clear? So the most important thing in this question, actually this is like a chain type question, am I right? Because in the first part we calculate the current, in the second part we calculate the current density, in the third part we are finding the value of the drift speed, and the fourth we are going to we found the value of the electric field. So the most important thing, if you made any mistake in the first question, what will happen? The rest of the question will be wrong, right? So please, while you calculate the current and the current density, so please calculate properly, otherwise the rest will be wrong. Understand? That's it. Thank you.